So one question about the applications is where could the UAM kind of transportation using the air for traveling or for transporting, where could it be most applicable? Or if you're looking at it from the business perspective, what are the potential markets? And of course, if you speak about markets and competition, you have to compare to the different means of transport and see where could you save most distance or most time if you use UAM instead of, let's say, road travel. So you want to see by how much the UAM flight would be shorter than the road travel for the different origins and destinations. And here is something that we can define for 2 points P and Q in your domain, in your area. You can say that the road stretch factor is this ratio of distance along the roads divided by the distance of the direct flight, of the UAM flight. Okay, so you're looking at the ratio of two things. One is how long it takes to get from P to Q along roads, and the other one is how far P and Q from each other in terms of the, well, this usual distance, the Euclidean distance, or again, as we also were talking in the previous lectures, bird fly, crow fly, or whatever the names for this distance, or we can probably call it drone fly or as the drone fly distance, but yeah, we'll put this in quotation marks. This is not a very well defined terminology and very widely known. But anyway, this is something which is more relevant to us. We look at the distance along roads divided by the distance for the UAM. And yes, so this stretch factor, it is factor because it's emphasizes that it's multiplicative thing obtained by taking the ratio of the distance along the roads to the Euclidean distance. And yeah, very often we would just say, stretch instead of the road stretch factor. Although there are different kinds of stretch factors that can be defined, and we will look at one of them again related to UAM. But before that, let me just give you an example of the road stretch factor. So, well, here is a screenshot from Google Maps. I was doing path from, I don't know, Central Body to Norrköping Airport. And well, along the roads, you have to take 2.9 kilometers. And then if you measure the direct distance, well, it's 202. So the stretch factor is the ratio of these two. The stretch factor here is 1.44. And of course, you can do any stretch factors, as many stretch factors as you want, again, using, for instance, Google Maps. Again, here I have from the central station, again, to the airport. And yes, you know how to do the directions and the distance along the roads. And then if you want to do the direct distance, you can use this measure distance tool, where you again click 2 points and it gives you the distance between them along the straight line. Okay, so that's as simple as that, the definition and the calculation of the stretch factor or the road stretch factor. There are also other stretch factors that may be relevant. And this is something that we had in the airspace availability lecture, that when the airspace is not available, the drones would have to detour to go around the obstacles. And again, there we could define this path stretch as the length of the shortest path around the obstacles divided by, again, the kind of ground truth, the minimum distance, the Euclidean distance between 2 points. And just to show you again a few slides that we had back in that lecture, here is well, the Bay Area, San Francisco area, and the pink here is the unavailable airspace. And then there are some of the points of interest, these stars, and the routes between them, avoiding the pink, avoiding the constraints. And yeah, we've been calculating things like this average path stretch between all these pairs of points, and also the maximum path stretch. What is the kind of worst path that has to go around. I guess it was between these 2 points, which would be connected quite close to each other, if not for the San Francisco airport, where the procedures that you have to avoid make you go really, really very much around, leading to really large value of the path stretch factor. And here are also some other examples. You may remember we were looking at different concept of operations, like what parts of airspace would be inaccessible for UAM, given different integration with the conventional air traffic management. And then again, you could see at different routes, you could see at average and maximum route diversion. Well, under this different conopsis. Well, here's another example. Again, green is the excluded, and you can see some of the routes and see how by how much the UAM would have to divert. And again, something that, that was shown also in those slides, that what you have as obstacles and as a consequence, what is the path stretch really depends on the area in which you're operating. So in particular, this hideous path stretch of factor 9 for these 2 poor points was due to the fact that we couldn't really go outside the boundary of the UAM region. If you were to enlarge this, then you could go between the same 2 points with a much shorter path with still large stretch factor, but not as large as 9. And then, yeah, and the question is, how do you really decide in what region the UAM operates, or whether the providers will have to pay for square mile? Well, that's far outside the interest. So here is again just some of the pictures of the path stretch and how the route diversion plays a role in it. So of course, just looking at stretch factor alone is not giving you the full picture. It's kind of a quick way to understand where you might want to go through the air instead of going along the roads. And there are many other factors that go in, like, yeah, well, airspace availability, we were just talking about it. In some cases, you may not be allowed to fly direct because of the noise. And in some cases, well, there could be a really good idea to use the air, but maybe there is no demand between these particular 2 points. Anyway, more integrated approach is needed and is being looked at by the businesses like Uber Elevate to understand where they want to have the origin destinations of their flights, which is again pretty standard thing in any kind of transportation, or even more general. You cannot solve the large problem, so the holistic view is much needed. But if you want to solve problems, then you usually break them into smaller problems until you have a problem which you can solve, and hopefully it resembles the original problem that you needed to solve from the very beginning. Okay, looking more generally at applications of drone technology, you may split them into several clusters, so to speak. And one of them is, of course, the transportation. And the transportation, well, you can transfer passengers or goods, which is sometimes called logistics or freight, as opposed to passenger transport. And the passenger transport most likely will start from piloted, well, with pilot on board, not remotely piloted or not automatically piloted drones or air taxis or whatever you want to call them, whatever they are called, but maybe later going also to unmanned. And yeah, there could be this kind of more civilian applications like air taxis, going from airport to somewhere else and just between 2 points. And there are these maybe questions of, bringing doctor to a patient or patient to the hospital, like they do currently with helicopters, so more these kind of government applications. And again, with the transfer of goods, there are also many different kinds of goods that you may transfer, but maybe the common and the medical, especially in this emergency medical services, I guess those may be the most appreciated, at least in the very beginning. And if there is a business case or there's support from the government, then those may be some of the things you may see pretty soon. In fact, in some places, as you may know, they are already being done, both in Switzerland, where they transfer blood samples, and you know, this whole zipline project where they use drone to go over places where there is no other transport. Well, they're good applications. But you don't have to be particularly important for the mankind to use drones. You can use drones for fun as hobbies. There could be racing drones, you know, who is the fastest and most precise, and so on and so forth. And then there is the full suite of applications for drones when they doing telemetry data collection, mapping, and other things. So these are envisioned as being only unmanned and similar with the goods transferred. So in general, we're trying to get rid of the pilots and have smaller things flying goods around. So maybe only when we transfer passengers, we would have to start with crewed or piloted onboard pilot operations. In all other applications, they will most likely be unmanned. You don't want to have a person flying a drone just to gather some data. And yeah, again, there are so many different kinds of data that you can gather looking at the rural areas and landscape and the infrastructure monitoring for various reasons. Weather, again, I'll speak more about that. You may want to send drones into hazardous area, traffic monitoring, search and rescue, security, and many, many more. So these are just some of the classes of applications that are envisioned or already being in use by drones. All in all, there are lots and lots of applications. In fact, you might have seen this in the Sora video from Lorenzo Morzilli that you had to look at. They say that when you try to classify something about drones, you always fail. And maybe there is a good reason, because there are so many different applications. We don't have to think about what the drones will be doing. And that's one of the reasons why regulations are risk-based and not trying to understand what the drones are doing. Businesses, business. We can nevertheless classify missions as we did in the previous slide. And in terms of the path, we can see what kind of paths the drone takes. Is it a straight line? Does the drone go in circles to inspect something? Is there a search and rescue mission when you're trying to cover a certain area? Or is it completely random because UAM is just for fun? And going slightly more technical, but not too much, for every mission, you can think of what would be the user preferred route. So what would the operator want to do? And this route could be stated as the word over this alphabet, where you have letters L, C, Z, and R for the linear part, circular part, zigzag part, and the random part. And for an example, if you're doing search and rescue, then probably you fly into the place, then you're doing the zigzag to cover, and then you're flying back. If you're doing inspection, you go into the place, then maybe you're doing circular route, if I don't know if it's a building, and then again going back. And I'm challenging you in the homework to find more applications. Well, not necessarily find yourself. I'm giving you, the links of applications, so lists of applications like on Wikipedia or in the PwC report, but there are also many other lists, and try to classify these missions using the words from this alphabet and see if this alphabet is rich enough, or maybe there are some other missions which are not being easily classified or described using this particular alphabet. And then last but not least, we don't go into it, but again, we posted a video on how drones could be used for mass testing. Again, that's an application that probably we wouldn't, well, I wouldn't say wouldn't envision, maybe people were envisioning it, but which wouldn't be so pressing until the last year. So in particular, this paper that we wrote back then got featured in Daily Mail news, and Daily Mail is not really any research magazine or anything like that, but still that seemed to be interesting enough. So I hope you will also enjoy watching the video. It's again about 20 minutes with Leo presenting it at Transport Forum or somewhere else.